Okay, here are the notes that you had right before spring break. You had just the notes to copy and you did not have me video them. So I have the notes still here. I'm just going to go over the examples. Everything's going to be written in, but let me just talk about it a little bit more. Maybe can help explain this next unit over chemical reactions. So it says here that chemical reactions or chemical changes. So the process by which atoms of one or more substances are going to be rearranged, and when they rearrange, they're going to form a new substance. So the atoms are actually going to break apart and join back together with different atoms. Well, here are some signs. Good puppies like to chew stuff. Good, the G stands for gas production. P stands for precipitant, which is a solid. L is going to be for light produce. T is for temperature change. C is for color, changing color. S is for smell. So out of those five, if something like this is occurring, then that is a sign that a chemical change or a chemical reaction is occurring. Okay? Gas is produced, right? Or formation of bubbles. A precipitant or a solid is formed. There's a gain or loss in energy. Now, how do you know that this energy is gained or lost? Because light is produced, like 4th of July fireworks, or the temperature is going to change. It's going to get hot or it can get cold. Either one. A change in color, and an odor is formed or it starts to smell. Those are all signs of chemical reactions occurring. Again, what happens with a chemical reaction? The atoms break apart and they form a new substance and they come back together with different atoms or different elements. Let's go ahead and keep going. So it says here on chemical equations, okay, a chemical reaction is represented by what we call a chemical equation using words or formulas. We're going to start off with our reactant and we're going to end up with a product. R stands for reactant. The arrow stands for a yield sign, means that's where it's going to, and you end up with a product. Parts of a chemical equation. The reactant is the beginning part, kind of like when you're going to bake a cake. You start off with the cake mix, the eggs, the vegetable oil. All of that would be on the reactant side, the beginning. That's going to be the base or the back end of the arrow. The product is where the head or the point of the arrow is going to be at. And it's going to be what's formed afterwards. So for an example, you have your eggs, your cake mix, you're going to have your cooking oil, your water, mix it all together, and you end up with your product, which is a cake afterwards. The arrows are there because they actually show the direction in which the reaction is going to take place. 99% of the time is going to be from the left to the right, but you may see it from the right to the left. Or, believe it or not, you might see it where there's two arrows, one on top of each other, meaning that the reaction itself is going back and forth over and over from left to right and from right to left. Okay? Physical states. So when it comes to chemical reactions, behind those elements that you're going to have either, you could have an S, a G, an L, or an AQ. S stands for solid. G is for a gas, like oxygen, right? O2. L is for liquid. Aqueous. AQ is used when a substance is dissolved in water. Okay? So let's go ahead and start off with it. You can have chemical reactions written in words. Okay? But it's a lot easier to write it in a shortcut where we write the elements symbols instead of the words. But you can have them in the words. For an example, it says here, burning carbon in the presence. That means that carbon plus oxygen forms, so those two equals carbon dioxide. So carbon plus oxygen, but remember it's a diatomic, so a 2 goes behind it, yields carbon di to oxide, CO2. And look at this. We're going to get into it in the next page, but balancing chemical equations. The amount that you have of the atoms on the right side must always equal the amount of atoms you have on the left side. So the right side and the left side, or the left side and the right side. They have to equal each other. Sometimes you have to do the balancing, but here it actually balances itself out. Let's look at the next one. 5 grams of carbon reacts with. That means that you're going to combine it with. So 5 grams of carbon reacts means plus 5 grams of oxygen, 5 grams of O2. Why? Because it's a diatomic. And because, remember, I told you, you need to memorize those diatomics using the 777 rule. Are going to form, look at this, a yield sign. Those two combined are going to make 10 grams of carbon monoxide. Carbon monoxide. There is not going to be a 2 there. This 2 is not going to carry over. Okay? Now, this was blank. And the reason why it was blank here was because you needed to see that 5 plus 5 is going to equal 10. Because the law of conservation of mass tells me that if I have 1 cake box, I'm going to end up with 1 cake. If I have 3 cake boxes, I'm going to be able to make 3 cakes. However much you start off with equals the amount of product you're going to end up with. Always. There's not going to just poof, be gone. You may lose it because of gaseous, and it may evaporate out because of the gas. But if we were to keep all of the material, including the gas bubbles, however much you start off with, should end up with. So, it says here, just so that way we'll know our states of matter, right? Solid, liquid, gas, and don't forget aqueous, which means that it's going to be a solution that was, remember, dissolved in water. AQ stands for that aqueous. Okay? And we're going to talk a little bit more about aqueous solutions. Let's turn the page. Again, this is just practice, so I'm not going to take a grade on it. I just want to clarify a little bit this balancing chemical equations. I know doing online class is not easy compared to the face-to-face, and so that's why I wanted to video the notes just to kind of go over it for you. Please use the notes and use those homeworks. Again, the homeworks are also not for a grade, but I want you to use them so that way when you take your quizzes and tests online, then hopefully you'll have a little bit of reference to help you with. Now, again, I talked about the law of conservation of mass on the previous page. Here it is again. We know that matter cannot be created nor destroyed. The amount of reactant you start off with must end the amount of reaction or product you have at the end. Balancing chemical equations. Now let's go into what we call balancing. Balancing equations, it says here, each side of the equation has to have the same number and, that's a key thing, the same type of atoms on each side. If I start off with hydrogen and oxygen, I have to have hydrogen and oxygen on the other side. I can't end up with gold. I can't end up with silver. I can't end up with chlorine. Whatever type of atoms I start off with, I end up with. However, amount of number of atoms I start off with, I should also end up with. And that's called balancing. Okay, that's really important on the next unit because we're going to get to what we call stoichiometry. In stoichiometry, you have to be able to make sure that your chemical equation is balanced. So let's go ahead and let's look at this. It says here that the subscript, which is the little numbers, tell you how many atoms of each element are in that compound. The coefficient, which are the big numbers in the front, which provide the lowest whole number ratio, remember we talked about that on the last unit, of the amount of all the reactants and products. Let's go ahead and talk about balancing. First thing is you need to write a skeleton equation. The word skeleton equation means you just really need to write down the actual elements that you have on both sides. Okay, so not even counting the amount of atoms, but write down the actual element like hydrogen and oxygen, hydrogen and oxygen. And they need to be the same type on the reactant and the product side. Step 2, you need to count the number of atoms of each element on the reactant and the product side. And they need to be counted separately. Once you do that, you need to make sure that both of them are actually going to be the same number. If they're not the same number, that means that it's not balanced and you need to balance it. Now, here's a key important part here. I'm going to go ahead and underline that because this throws a lot of students off. Sometimes it throws me off. Polyatomics, unchanged on both sides, count as a single unit. Remember when we were talking about polyatomics, if it was just one, we didn't put a parentheses, and if it was more than one, then we put a parentheses around it. Okay, now here, if it's a polyatomic and it's the same amount on both sides, you kind of just consider them as if they were like glued together. Okay, could you separate a polyatomic and count it out that way? Yes, you could. Sometimes it's easier just to go ahead and separate them. Sometimes people like to count or balance them with them being as one single unit. That's only if it's unchanged. If the polyatomic is going to break apart in the chemical reaction, then you need to count each atom separately. Let's go ahead and keep going because we'll see that in a little bit. Part C, change the coefficients to make the number of atoms in each element equal on both sides. Hold up, let's go back. This is the number one important part that we need to know. You can only, I'm gonna put it right here. You can only change the coefficient number, meaning you are unable to change that little bitty subscript number. You can't change it. You can only change the big number in the front, which is called the coefficient. And so you have to change it until both sides equal the same amount of atoms. Do not change the subscript ever. Multiply the coefficient, the big number, by the subscript, the little number, to determine the new amount of atoms you have for that element. We're going to practice it soon. It says here, leave hydrogen and oxygen until last. That's kind of a hint or a clue. And there's a few reasons why. Mainly because that's probably going to be an acid-base reaction and it's going to form H2O. But they're just best to leave until last. It's just a clue. You don't have to. These two elements often occur more than twice in an equation. So we'll look at them later. Make sure that the coefficients are in the lowest possible ratio. Meaning, let's reduce it. And then it just says double check. We're going to have to practice this a little bit before you get better. Again, starting tomorrow, every week, starting on Thursday, the test will be available. The test will be available from Thursday through Sunday. Okay? I will not have the test available Monday, Tuesday, Wednesday. I'm going to at least wait till Thursday before the test is available. Come Sunday, though, at 11:59, the test will no longer be available until the rest of the school year. Okay, but on Sunday, I will go ahead and have the new unit there available for you. So tomorrow, which is Thursday, this test will be available. You get one shot to take this test. There's only 10 questions though. Okay, they're all going to be multiple choice A, B, C, D. Okay, please use all your material with it. And if you want to do the test on Thursday or Friday, go for it. If you want to wait till Saturday or Sunday, it's up to you. I have it on the calendar. I know it looks a little worry like there's so much to do all the way to the end, Saturday or Sunday, but you can definitely do it earlier. But I just wanted to leave it available to give you more time to do it, just in case if other work needs to be done sooner. Let's go ahead and continue because we need to practice. And again, I told you that the notes are already filled in for you. But I'm going to go through and write it all in. It says here we have zinc S solid plus hydrogen 2 and I see SO4. I know because I've been doing polyatomics and you know now after all the polyatomics that that's actually a polyatomic SO4. Aqueous, meaning that this is dissolved, yields hydrogen 2, remember diatomic, gaseous, plus zinc, SO4. I just put parentheses around there. If you want, you can put parentheses just so that way you can see that the SO4 I'm going to leave here just like how it says over here. I'm going to leave it unchanged. Zinc, H, and SO4. Could I separate the S's and the 4 and the O's? Yes, I could. But since it's SO4 here and it's SO4 over here, I'm going to leave them as one unit as if they're glued together, SO4. Let's go ahead and let's count out. Ignore my numbers here, but let's count it. There's no number in front of it, so we're going to assume that there's a 1. There's no number behind the zinc, assume that there's a 1. 1 times 1 is 1. So what I like to do is I like to list all of my elements first, and I draw this wall. And this side is going to be everything over here. This side of the wall is all the atoms over here. So I have 1 times 1. Again, ignore my numbers because those are the answers already. Is 1. Ignore it. 1 times 2 is 2. 1 times 4, or well, remember, if I put a parentheses around it, that 4 actually only goes into the oxygen. So I put parentheses so that way I know that this is one single unit. There's really a number 1 invisible behind it. So 1 times 1 is 1. There's only 1 SO4 on this side. Let's go over here. Ignore it. 1 times 2 is 2. 1 times 1 is 1. 1 times, again, 1 is 1. Let's look at it. Zinc, 1 and 1. Check. Hydrogen, 2 and 2. Check. SO4, 1 and 1. Check. Since I have the same amount on both sides, I am balanced. Let me tell you now, on some test, you're going to have to put a number, okay? If this was you doing it on paper with me in the classroom and you left it alone and you never put a number 1, you left it like that, that is perfectly okay. Because we know that if there is no number, that we assume that there is a number 1. But on the test itself, when you take the test, if this was a question on the test, I would be prepared to do 1, 1, 1, and 1. Okay? Let's go ahead and look again on the next one, number 2. Yes, the answers are already there, but let's practice and let's talk about it. So, sodium hydroxide, you know how to name these elements and how to write them down, the compounds. And so you might see the name and you need to write it into the actual compound it is. Sodium hydroxide, OH. Sodium, which is a +1 charge, hydroxide is a -1 charge. Crisscross those, NaOH. Okay? Again, that's all I wrote down. This too is the actual answers. So ignore those big coefficient numbers. Okay? Next one, calcium bromide. Calcium, Ca, +2. Bromide, Br, -1 charge. Crisscross those. What I wrote down originally was CaBr2. This 2 came over. You know how to do this. Yields calcium hydroxide, CaOH, +2 and a -1 charge. Where do you get those charges? From the top of that group number. Remember, you need to go and see, does it need a plus charge or a negative charge, so that way it can have a full valence shell, right? It's not like if it's in group 3, then its charge is always 3. Or group 7 is going to have a group charge of 7. No. Group 7 is going to have a 1 charge. Let's go ahead and let's keep going. Sodium bromide. Na, +1 charge. B, -1 charge. Crisscross those. So Ca1, O, parentheses 2. Because this 2 goes to both of the H and the O. They are grouped together as one thing. Over here, you're going to write down Na1. Don't write a 1. It's invisible. Br1. It's invisible. Now, ignore the coefficients and let's go ahead and count our atoms. We have Na, OH, I wrote down the polyatomic as one unit because look, here it is here, and here it is here. Could I break the oxygen and hydrogen? I could, but it's easier to keep them as one group. Calcium and Br. So those are the 4 different elements. Now let's look. 1 times 1 is 1.